Cool. I'm going to talk about a bunch of things, and ideally you'll learn something today. So hopefully something that you can apply to your own situation, whatever that may be. So you'll learn about synthetic monitoring, hopefully, and you'll learn about what it is. If you don't know already what it is, I'm sure that most of you have seen it in some form or another and probably worked with it already. So how it's going to be different from other kinds of monitoring, explaining a little bit of the love-hate relationship that we sometimes see with synthetic monitoring, why it can be valuable and why it can not be valuable in the other circumstances, what to use it for and what not to use it for, how to use it properly so you don't get randomly paged in the middle of the night or you avoid that happening to other people as well, and some unfortunate situations that can happen when you don't use it properly. And I'll sprinkle in some Atlassian-specific examples, mainly about Jira, because that's the team that I work on. So mostly everybody here is here of their own free will, I hope. Like, let me know if you're not. Or you're passionate about SRE, or your employer is passionate enough about SRE that they're sending you here like as a human sacrifice. But hopefully that you want to learn something today, and yeah, I'm happy, like super happy to be here and you know, talk. So who am I? I live in Sydney, Australia. I've been in the Jira SRE team at Atlassian for 4 years and 3 months now, which I guess is a long time to stay in one team, but it's been good. So lots of stuff going on, building stuff, doing things, database infrastructure management, new technologies and things like that, working on services and tooling, and of course on synthetic monitoring. So why am I qualified to talk to you about this today? I'm the main developer and owner of a significant part of the ecosystem of synthetic monitoring at Atlassian, specifically the part that runs for Jira. And at least maybe 30 or 40 different Jira development teams, Jira product teams, use these services and tooling to manage their synthetic monitoring. And then I work with the observability teams to advocate for Jira and our use case for internal tools that we have. So what is synthetic monitoring? These are AI-generated images. So one of the robots is missing a computer there, but you'll see some more questionable images later. The synthetic monitoring is ideally defined as tests or checks, you could call them, that emulate a real person accessing the system. And you typically would alert on failures like any other form of monitoring. It's typically end-to-end testing. The meaning of the word synthetic, it's got two main meanings. The first one is it describes something that you can prove is true or false through experience. And the other meaning of the word is it's synthesis. It's chemically made that imitates something natural, like synthetic fiber for carpet or synthetic mattress for foam or synthetic turf, whatever. So that pretty well describes what synthetic monitoring is at a very high level. What does it actually look like in practice? So I'm going to ask a few questions, quick poll. Raise your hand if you're familiar with Selenium WebDriver. Okay, that's like 70% of people. And then, yeah, this little example is a very simple check or test that just goes to google.com. It waits until the page title is Google. It waits for 1 second or 1,000 milliseconds to do that. If it succeeds, it'll say test passed, otherwise test failed. And this is the basic premise of browser-based synthetic tests, where you have a browser and you do something in the browser pretending to be a user, and then whether it works or not, your test will pass or fail. Raise your hand if you think that this is this form of monitoring is good and useful, if you've generally had good experiences with things like Selenium WebDriver. Cool, that's almost no one. That's the answer that I expected. And then, yeah, raise your hand if you've typically had bad experiences with things like this. Like a few more people, yeah, maybe 20, 30%. So yeah, this talk's going to be more than just Selenium, so don't worry. Yeah, we're going to go through a bunch of other things. So some other types of synthetic monitoring. They are typically end-to-end, although some are more end-to-end than others. So you've got browser-based automated testing, which is sort of what this is, where you have a browser and then you do some automatic navigation around that browser, like a user would. Like you can think of a bit of a cursed analogy as paying someone to sit at their computer all day clicking through a website every 5 minutes to make sure that it still works. which actually has happened. I know someone that was paid for that for some reason. And then you can also have things like per page tests. So you load a specific page of your website, and you can measure the component load time, sort of the same stuff you'd see in Chrome DevTools view. And then the main other type of synthetic checks is endpoint testing. So simply just polling an endpoint or API and expecting a certain HTTP response code. And that's less end-to-end because you're not going through the front end and all that, but it's still like technically classified as an end-to-end test. You can have different running frequencies as well. So you can run this test every 2 minutes or every 1 minute, or if you really wanted to, you could run it every 30 seconds. But you can also have one-off tests. So you can run this just once after you deploy a new version of your app, and maybe that's useful to make sure that you didn't get anything terribly wrong. And what are the popular tools? So there's 4 main frameworks, and there are definitely other ones apart from these 4 I'll mention, but these are the 4 sort of less proprietary frameworks. Selenium WebDriver is the biggest and oldest one, started in 2004. Then you've got Playwright, which is probably the coolest new one at the moment. Then Cypress was once the coolest, made in 2018, and then Puppeteer was 2017. These are all good. Honestly, there's not that much difference between them. There is definitely, there are differences, but yeah, you've got other proprietary players like Datadog, New Relic, AWS, CloudWatch Synthetics, and then some of them have a bit more customizability with some certain things, but also you get locked in with certain vendors. So yeah, these 4 are close to equivalent. Cypress has a very good developer experience with you can record actions in the browser and then play those actions back. It writes the code for you in a way, sort of. And Playwright will run the fastest, but only by a small margin. Speed isn't really a massive deal with synthetic tests. It's sort of just the browser will load or it won't load, and you'll just go through at the rate limited by your backend. And then Selenium, it's super old, so 2004. It's got great support. Super old, 2004. I shouldn't say that. Some people might not like that. But yeah, it's an old tool, so it's got thousands of Stack Overflow answers and whatnot. It's using WebDriver as well. So WebDriver is like a remote control interface for user agents. It's like middleware that sends your script commands to the browser, which is good but bad. Like it's good because it was pioneering technology at the time, but now it's sort of dated when you have alternatives like Chrome DevTools and the DevTools API. That gives you a deeper level of control into the browser, and it allows you to do things like automatically waiting for elements to appear in a smarter way than you can do with WebDriver. And yeah, like Puppeteer and Playwright have some good low-level control. Microsoft poached some Puppeteer engineers to build Playwright, so if that means anything to you, I guess you can prefer Playwright. And then yeah, if possible, like you should just use one system to manage all of your observability stuff. So if your existing observability system has a synthetic monitoring provider, just use that. Like there's not really that much of a big difference between them all, to be honest. Atlassian, we just let developers choose between whatever they prefer, because even though it is nice to standardize on one framework, it's not a big deal in this case. And yeah, software accumulates issues as it ages. So because most of our initial tooling was built on Selenium, that means that there are some things in our Selenium implementation that we would prefer not to be there. So we can re-implement that properly by moving to a different technology. It gives us a good excuse. And then sometimes you just have to build something in-house as well. Like if you have a really complex product, for example, like Jira, it's got lots and lots of stuff going on. There's lots of services that support it, layers to it, I guess. Then in-house synthetic monitoring is pretty necessary in that case. For example, if you've got custom inter-service authentication protocols, it's probably going to be pretty annoying to try and route that through like a third-party monitoring solution. And yeah, some of these as well have cloud services too. So generally, like we heard this morning, that the cloud is really expensive. Definitely is really expensive. And then managed cloud is really expensive, especially if you're doing lots of things in the managed cloud. So yeah, trade-offs. So let's talk about pyramids. And some of you may notice that the third pyramid here is missing because these are all AI-generated images. So just in case anyone's from Egypt. Everybody is familiar with the pyramid. though you may not know it immediately, the testing pyramid. I'm testing you. I'm going to keep this simple. So there's manual at the very top of the testing pyramid, end-to-end near the top, integration tests is near the bottom, and then unit tests at the very bottom. And yeah, I like to think about what the testing pyramid really means. So synthetic tests sort of fit mostly in the end-to-end bucket. But generally, like, this pyramid's pretty unrealistic. It's idealistic. Most orgs will do a lot more manual testing than they like. And generally, the pyramid is a bit of a confused analogy. It's good and bad. It's good because the width represents the quantity of tests that we want to have. We want to have lots of unit tests and like next to zero manual testing. It's simple. The pyramid's like a great big strong monument thing, which implies that we should be building it and writing tests. It's bad because it sort of implies that the higher you go up the pyramid, the better, which is not great because manual tests are not good. I don't really need to explain that, I think. It implies that it has to be built from the ground up as well. So you should be building a unit test first and then your integration tests next. But sometimes that doesn't happen. You just can't. If you have a very poorly tested application, then you might want to prefer building end-to-end tests rather than going straight into getting everything else sorted out, which can take a long time. For a big legacy app that hasn't been well tested, whatever that may be, it might be better to go for a higher level test to start off with. And yeah, each part of the pyramid has its rightful place. But yeah, unfortunately, even manual testing has a place, although we'd like to minimize that place. So what are some of the other possible configurations of this pyramid? If we invert the order of the pyramid, so the order of the items in the pyramid, then we end up with like what's represented as an org that has a ton of manual tests, but still wants to get to those unit tests at the top there. This is usually what happens when you have a lack of testing discipline. What if we flip it on the horizontal axis? We end up with an ice cream cone. That's one of the analogies that's been used to describe this configuration. It's sort of more like a funnel. I'd prefer to think of it as. This is the nightmare state where the manual tests are prioritized at the top, and then you've got this one. This one is pretty good, so let's zoom in on that. It makes much more sense to think of it as a testing funnel that catches bugs, similarly to how a sales funnel catches customers, except in the sales funnel, you actually want customers to get to the bottom of the funnel, but in this one, you don't. This isn't a typical funnel as well. So I've snuck in some references to Australia. So this one is inhabited by the venomous Australian funnel web spider, which they're almost as dangerous as drop bears, for those of you familiar with drop bears. It's built its web in this funnel. And yeah, I'm not going to pretend this analogy doesn't have holes. Suspend your disbelief, please. Bugs fall in and get trapped. So unit tests are our first layer of defense. They can be run early and often. Should catch most bugs. End-to-end tests take longer, not always guaranteed to run as part of CI, and then manual tests should never be guaranteed to run. The point that I'm getting at here is that end-to-end synthetic testing should not be our main bug catching method. That may seem really obvious, but if some functionality is broken in prod, it's sometimes quite easy to just add a synthetic test or an end-to-end monitoring test to cover that bug, rather than attempting to do some more sophisticated, long-term fix. So yeah, creating monitoring after an incident shouldn't be done just because there needs to be at least one action that comes out of the post-incident review. Yeah, there are a few incidents in Atlassian like this where, for example, a particular issue in a Jira ticket wasn't visible or editable, and then in the PIR, post-incident review, the teams decide sometimes they'll just do a synthetic test to make sure that field is there. That's sort of a lazy choice. It's an easy action, doesn't require much thinking. You just, if we had this test, we would have caught this bug. In that case, should we really have an incident? We can just reject the incident if it wasn't worth creating one in the first place. In that case, it was. But in other cases, sometimes, if you can only think of one possible action for your incident, then maybe it shouldn't have been an incident, or maybe you just need to get some advice from somebody else and figure it out together. Is synthetic testing really the best option? Like, often, no, it's not. Should we have an end-to-end test that then tests every single field in every Jira ticket? That wouldn't really be very good. And it's expensive to run. They're quite expensive to run, and they take a little bit of time. And what about the other things that we're not checking for that also could have broken? How granular should we go? Given that synthetic checks are like pretty flaky, is the owning team even going to have the alerts enabled when this check eventually fails? Are they even going to pick it up? So this is sort of the meat of the presentation. Why are synthetic checks so flaky? Like, they just fail unexpectedly. They might page you randomly. They just don't really work super well. That's why I think everybody is frustrated by them. So most of the flakiness comes from lack of awareness of all of the possible points of failure that can lead to flakiness. So once we're aware of all the possible factors, we can start to fix things. We'll focus on browser-based tests because they're typically the most flaky. Firstly, the scope of the test is huge. You've got many potential points of failure. It's going through the front end in the browser. It's obviously talking to the back end whenever it has to go and fetch data. It's talking to a real database, not a mocked database. Integration tests and unit tests will usually mock things. You've got the test code itself. You have to rely on the developer to have written a good test. You've got dependencies of the test that aren't usually the same as the ones that the customer is using. So in a test, you've got like the test authenticator service maybe that authenticates the bot users that need to run the test. You maybe have the test runner itself and so forth. And you've got multiple features and pieces of functionality along the path of your synthetic test. So when you load the homepage for your application, you're testing the homepage, and then you're navigating somewhere else, and then you're testing that page, and then you're testing everything else on the page sometimes to make sure that it loads properly. So there's a lot of stuff going on. And then in the test code itself, you've got like sleep statements. This is like #1 crime for synthetic tests. It's like, do not write time.sleep in your synthetic test to wait for an element to load. You should always just use a function that, an observer function that looks for elements on the page and will then return once it finds it. But you can set a timeout, but that's a much nicer way to do it. And then, there's a mismatch between the real user experience and the bot experience. Like, a real user can adapt to things that happen in the browser, but the bot can't. So if you have a new onboarding message, like you load the site for the first time, and a pop-up happens that says, try this feature, it's really cool, and the bot's not going to know what to do with that. It's just going to fail. And then someone's going to get paged, and they wake up and watch the video playback of the synthetic test and then see, oh, like, I can go back to sleep now. And then they mute the alert and never see it again. So it's flaky. So what is the difference? So some of you could be aware with RUM. What is the difference between RUM, real user monitoring, not alcohol, and synthetic monitoring? So they're pretty comparable, but they have some different use cases. RUM is more talking about actual real user journeys. Like, what are they actually doing in our application? Not what we think they're doing, like what they're actually doing. So when you're collecting real user metrics, that exposes edge cases from customers that you hadn't thought of. But it doesn't guarantee that you're going to get data frequently, because you have to wait for the customers to actually go on that path to collect those metrics. So it's not guaranteed to give you advance notice of errors. Like, you only find out when the customer finds out, which isn't great. And if only a handful of users are experiencing a particular error, then how can we actually verify that we care about those errors? They could be running a load test and expecting poor performance. They could be trying to hack us, like doing a completely unsupported operation, like injecting some weird JSON somewhere. When you've got a big enough production fleet, like, these things just happen all the time. And you do get some other good stuff, but you really just only get data points when customers do things. Whereas with synthetic tests, not to say that they're better or worse, they're just different. It depends on your use case, but they can sort of run wherever, whenever, however you like. They can run in staging. They can run every 2 minutes. They can run every 10 minutes. They can only run after deployments and so forth. And the errors are reproducible. You can just run them again to make sure that it's actually failing, or just wait for it to run again. And then, depending on what your app looks like, you can do one or both. RUM and synthetic monitoring. What does synthetic monitoring look like in Atlassian? So we've got this service called Pollinator. It's highly bee themed. It's a custom runner to run pollinator checks, we call them, so synthetic checks or synthetic tests, at the scale and level of customization that Jira and other services at Atlassian require. So it's like the workers are little bees in the hive, they're little EC2 bees, and they run synthetic checks for any service. So the service that I'm most concerned with is Jira, because that's what I work on. It's got a good selling point of having like a massive feature set, but that makes it really hard to test everything to make it work. So what does Jira look like in the context of synthetic checks? So Jira runs on AWS in at least 10 different AWS regions. We have maybe 300 shards in Jira, where each shard is just a group of compute, cache, and database resources. It's multi-tenanted, where each tenant is like a customer site. Each tenant, there could be up to 20,000 tenants in a shard, and it's spread across 5 to 10 Postgres instances in that shard. And then in each shard, you've got two what we call synthetic tenants. These are just dedicated for handling synthetic monitoring traffic. And you've got one active one and one inactive one. So you can sort of swap between the active and inactive when you need to clean one of them up. So our mission, I guess, is to maintain Jira's reliability and improve it where we can. So how do we actually do that with synthetic checks? So we've obviously got a bunch of other non-synthetic checks monitoring, but because the focus of this talk is on synthetic checks, I won't go over that too much. But other application performance monitoring, there's plenty of other stuff like, you've got error rate, latency, like percentile things, saturation by resource, by endpoint, by team, whatever. But why we also value synthetic checks is because we can monitor individual features or capabilities of Jira. So whether or not a feature is working, for example, viewing an issue, is best determined by the user of the application, not really by error rate or latency. Those things can inform us, but really at the end of the day, like if the experience works or not, that's what we care about, and that's what synthetic monitoring can be quite good for. So you can open up a video of what happens in your synthetic check in Pollinator. Pollinator will save that. And yeah, things in prod can just stop working at any time for any reason. Despite passing thorough testing in staging, then a feature can just stop being good. You can have a failure in an external dependency, like pretty rare, but you can have AWS go down. That's happened like more than once. But failures in internal dependencies as well, like you can't log in maybe. Maybe the login portal is just broken. There's nothing that we can do about that in our team, but we have to wait for the other team to go and fix that. So we have to try and figure out how to not alert people for something that isn't their problem. And then, what if the customer just tries a really unexpected path? We just want to know what the customer's doing and have empathy with the customer for our testing. And all of our other metrics and alerts could imply healthiness, but there's a chance that you could pick something up with a synthetic test that you couldn't pick up with logs or any other kind of APM. And we get per region visibility as well. So how do we actually do all of this stuff? So we've got another tool called PM2, which stands for Pollinator Manager 2. Pollinator and Pollinator Manager 2 sort of work together for Jira. You can think of all of the following as like a recipe for good synthetic monitoring. So each development team in Jira has their own repository to manage their own set of synthetic checks. You get an easy template, a Jira-specific template to set up your checks. You get managed execution environments for each of your checks. So they'll run with specific versions of dependencies to make sure that it's tightly controlled. They run in hives, hives in Pollinator, like beehives for per region redundancy. And you've got a suite of documentation and best practices that we try to give like all of the tools that people will need to write really good tests. So one of the things that is really important as a best practice generally is if you're creating data in your product through a synthetic check, then you shouldn't do that endlessly. For a check that runs continuously, like for example, every minute, if you're creating a Jira issue every minute, then when you create that check, it's fine, like no one's going to notice. But then 1 month later, when someone logs into the synthetic tenant and sees 1 million Jira issues in a single project, and then people are wondering why the database suddenly isn't working anymore, like that's a bit of a problem. That's happened a fair bit, but that's something that gets easier to manage as people become more familiar and teams mature and grow with synthetic testing practices. If one check depends on another check to create data for it, then you want to define a dependency between those checks, like ideally automatically. As I said before, like don't use sleep statements. You can also use the testing frameworks themselves to help you write the test. So Cypress and Playwright, I think, both have sort of a framework to record actions that you take in the browser and then convert that, at least partially, into code. And we provide a big library of helper functions. So if one team needs to do something like create a Jira issue in their test, then another team is very likely to need that as well. So they can just reuse this library of utility functions. And another thing that you don't want to be doing is logging in. Like you don't want people to have to log in or write their own custom login function every time they run a test. So we just provide some standard tools to help you do that. And then how do we determine where to run, like the appropriate granularity at which we should run our synthetic tests? You've got like a few options. You could granularity by target. The options are you could run it on every single Jira tenant or customer site. That's like a terrible idea because there's millions of those. You could run it on every single database instance. Still not the best because there are lots and lots. You'd probably just unnecessarily stress them all. You could run it on every shard. There are 300 shards. Getting a little bit better, but that depends on how many checks you have and how intense they are, like how many resources you expect them to consume. Or you can just run them on a subset of shards, which is what we currently do now. So bit of backstory, we did go a little bit too granular. Sort of organic growth led us to the point where we were running on every shard, but the shards had grown from maybe 90 shards a few years ago to now we have 300 shards. And the size of each shard hasn't really changed drastically. So that meant that the overall cost of the synthetic checks was just growing. And the other thing that compounded that was the number of checks that were being created. Teams just started finding them really useful, and they just create more and more checks. And there was just a bit of unbounded growth. So eventually, slightly shocking, that we saw that over 10% of all requests made in Jira production were coming from synthetic checks, which is kind of insane. These requests were cheap requests because some customers just do really strange things, like loading massive JSON or like whatever they want to do. Customers have some really strange use cases for Jira. But but overall, we saw that it was more than a few % of overall database usage on production. So that's sort of a lesson for what happens when you don't look after your synthetic monitoring, I suppose. So we reduced the granularity of that by only running it against a subset of shards because we found that we didn't really need to run it against every single shard. Like if one shard was having a problem, we'd probably pick that up through some other form of monitoring, and we didn't really need synthetic checks for that. And the frequency at which they run. So they were previously running every 2 minutes. Now they run at every 5 minutes to every 15 minutes. And we don't find that that's like a big sacrifice that we made, but it's worth it in the long run for the cost. 3 years ago, there are a relatively small number of synthetic checks, but it's grown a lot. You can also choose granularity by feature that you want to test or test themselves. So you ideally don't want to test niche things. You just want to keep them really high level. You want to do the main flows that your user would take throughout your application, the ones that you expect to always work, that are really important to keep good visibility of. And you want to make sure that you frequently audit your list of synthetic checks as well. Like you don't want to be having outdated synthetic checks that just use resources on production or on staging that just get ignored. And yeah, audit for usefulness as well. Like checks shouldn't be running that aren't useful to the team that owns them. It's sort of easy to leave them around. They're quite expensive to leave around though. Compared to unit tests, if they work, you're not going to delete them. But for a synthetic test, it's the same, but it costs money. So you can also use it for post-deployment verification. Synthetic checks are pretty decent at this, but with some mixed results. We generally found that unless they're tightly controlled or audited, or you only run a subset of them, then synthetic browser-based post-deployment verification is really risky when you try to use it to do things like abort deployments. If you have a deployment that's running and then you run post-deployment verification on the staging environment after that's finished, then there are all manner of things that could be happening in staging that could cause your synthetic check to break because of all the reasons that we mentioned earlier about flakiness. And you don't really want to be aborting deployments based on that. If you do, then you want to at least have a manual override button, especially if deployments take a little while. And yeah, we already have other checks that manage these sorts of things. Like we don't need to use synthetic checks for those use cases. It can be used to verify new regions. So when we rolled out Jira to Canada, we picked up a few things that we hadn't considered. Before we'd opened it up to customers, we saw that the CloudFront distribution config was a bit dodgy. It was just using an old URL, and then that was fixed. So that was a really good thing that we picked up that we wouldn't have probably found otherwise, because the application seemed to work fine, but when you were running it at scale, it didn't, or it was going to struggle. So you've got CI/CD as well. You can use synthetic checks pretty effectively in CI/CD. For the checks themselves, you want to make sure that you're not publishing flaky checks into production. When you publish a synthetic check, you want to have high confidence that it's actually going to work and pick up useful signal. So there are a few things you can do to make sure that happens. You can have automated soaking. So you deploy your check to the staging environment first, and then that runs against your production in staging. It runs against your product in staging. And if the check fails, then if it fails past a certain threshold, like it has more than X failures in 15 minutes, then we can say, yeah, we think this check is probably broken because it was working before, but now it's not. So we can stop it from getting to production. And then that means that once our checks do get to production, we are aware and we have confidence that they work. And for Jira deployments, we have some CI/CD. They're not post-deployment verification, but more like pre-merge checks. So when you're running synthetic monitoring, it runs before you merge it, it'll make sure that your code changes work. And then with alerting, when you have alerts on synthetic monitoring, really with any monitoring this applies to, but you want to have really good threshold-based alerting. So if you just get one failure, you don't want to care about a single failure somewhere, typically. Maybe you do. But if many checks are failing in only one area of infrastructure, then that's probably an infrastructure problem. And you don't want to alert a product team for an infrastructure problem. So the SRE team or whoever owns the infrastructure should get that alert. But if on many different parts of the infrastructure you've only got one check failing, then that's probably a product problem. So you want to go and page the product team for that. So you can set up automated alerting rules to do that for you. The other things that are good to do, just providing an out-of-the-box dashboard, which we have for synthetic checks. And yeah, managing the sites that they run against in production is also necessary. So yeah, they are really genuinely useful. We try to minimize the number of them and then make the ones that we do have really useful. So let's talk about maybe what we haven't done super well at. Ownership. So yeah, this AI-generated image didn't really come out very well. We historically haven't been great at ownership internally in Atlassian of specifically around synthetic checks. But we're sort of at a point now where we're comfortable and stable. So in the last few years, we sort of were having a bit of ambiguity around who owns what in synthetic checks, but you really need like strong ownership and maintenance of synthetic checks for them to work properly. This is something that we learned sort of the hard way. And that has sort of led to a model where developers own parts of the synthetic check ecosystem, so they contribute to how it works. It's not owned by any one team. We're sort of the overseer team, but we don't own synthetic checks. And that's actually worked, but that path to get there was not very easy and required a bit of trial and error. But yeah, communally owned tools can work. It's just kind of hard to get buy-in and to get people to want to contribute and making it really easy for them to actually do that. So yeah, it's this classic story of we built this handy thing, but now it's grown too big and like we really don't think we should own it anymore, but we just built it because we were in the right place at the right time. So yeah, sort of fending off support requests with FAQ pages, docs, like sorry, we can't help you with that. But like you really need strong ownership after a certain point, because after enough people are using it, they want new features, they discover bugs, they want to contribute, but maybe they're going to contribute in the wrong way, and you need to guide them back to the right path. And yeah, but we've reached a point now where like we've got to the point where we know that we're centralizing the tooling. Everything is pretty self-serve, and that's worked quite well. So other challenges, what happens when you run synthetic monitoring thousands of times on the same workflow? This is, yeah, not so good. So for example, there was a check that was running against Jira Dashboard's homepage, and that actually exposed an N+1 problem in the product code where database queries would just loop to check permissions for the dashboards instead of go in a single like bulk query. So we ended up fixing that and reducing the performance impact by 90%. But the irony is that it's sort of a bit redundant because synthetic monitoring was the main instigator of that problem. So it's like a bit of a something to consider, I suppose. Like you have scale problems that you create with synthetic monitoring, but you can also fix them. And you obviously don't want synthetic monitoring to be the only cause of these bugs. And yeah, what about like how we can make it better? Good synthetic monitoring configurations are pretty underrated, I think. Like everyone sort of just gives up when they think about synthetic monitoring. All the problems with flakiness, historically Selenium, like if you just Google Selenium, you'll probably find like rants somewhere. It needs a lot of love and care to operate properly. So it's really important to recognize the importance of the developer experience and developer joy in managing synthetic monitoring. And the tools can be pretty frustrating. Like writing a test can sometimes feel like writing CSS, like arbitrary front-end, whimsical novelties, like finding a different ID, because maybe an ID changed somewhere, and then your test breaks. Yeah, SRE, like we really need to be arbiters of quality and usefulness for the tools, so we can sort of make it better or worse for everyone. How do we generate awareness and sort of appreciation for synthetic testing amongst developers? So synthetic testing in Atlassian for Jira, developers, like thankfully they find it very useful and enjoy it, but that's not always the case. Like if they don't, then you need to figure out how to fix that. You can run a survey, you can do user interviews, publish it in a blog. We have like a really good blogging culture in Atlassian, sometimes too good. People write too many blogs. And how do we convey the importance of good synthetic monitoring to management? And that's so that it can be invested in appropriately. Advocacy for tools in general is quite hard. It's not enough just to like do the work. Sometimes it is, but sometimes it's not. So you need to convince management that you're doing something valuable by developing synthetic monitoring, which is not a waste of time, it would turn out. In the short term, you might feel like it is. This is pretty general. That applies to any tool or service. But in the long term, like you need to surface the work that's being done. So show the user interviews. And in particular with monitoring, if you're creating monitoring to prevent things, synthetic monitoring prevents incidents, then how are we going to prove that those incidents were going to happen in the first place? Like you can prove it. You can say that we stopped this deployment going out because our check was failing, but it's not as obvious of an impact as changing something that's got a very clear before and after. So yeah, there's a bit of like appeal to ignorance there. And then yeah, just track all of your work in Jira tickets if you want. No. There's always some level of ad hoc planning there. And then yeah, to wrap up, I mean, AI, I guess I got to talk about AI because I don't know, everyone's doing that. So big hype. Last week there was Devon. It was introduced as the world's first fully autonomous AI software engineer. It was a tireless, skilled teammate. I can say this is not strictly true, as I happen to know a software engineer called Devon who's working on the AI team at Atlassian. So there we go. The point is that AI is becoming pretty all-consuming. So how is it going to affect synthetic monitoring? A few predictions. So just making things more automatic generally. Determining the best flow for your synthetic check. I'm not aware of any solution that does this already, so maybe this is a good thing if you want to make a startup, or if you're from a company that already does something like this, then yeah, navigating throughout a website just based on a prompt. So like go to this issue and then click on the comment. If you were writing the code for that, then you'd need the ID of the issue, you'd need the selector in CSS, you'd need to then like wait, and then in the code you'd have to have a wait until this element is visible, and then navigate to this thing, click on it. If any of those IDs change, then your test could break. Ideally, you'd pick that up in pre-merge checks, but sometimes you wouldn't. So the AI can also probably do things like respond to unanticipated pop-ups that you weren't anticipating. Not just to write code in a specific way, but it can sort of change what it was going to do to make sure it's more closely aligns with what the customer would actually do. Like you're trying to emulate a real user, just writing code that pretends to be a user is not always the best thing. Pre-recording, so better action recording. So when you go through a browser to navigate through and record what you want the test to do, you can get AI to sort of do that better, more aware of the realistic flow. Automated detection of complex rule violations. So best practices, for example, they might not be followed, and you can't really pick that up with SonarLint or something like that, especially if someone is new and didn't really bother to read the documentation. You can detect that with AI. And then automated insight analysis. So like these page resources take too long to load. You can compare and combine that with real user monitoring. To suggest, you can suggest synthetic text to create based on RUM as well. So that about wraps it up. So I've had a great time. I'm keen to go touristing around San Francisco, and yeah, welcome any questions.